In this video, we're going to go over completing the square. Completing the square is a process for factoring that you may have talked about in Algebra 2, but if not, it's okay. When we need to use this is sometimes we are given equations that aren't in conic form or aren't in standard form. This looks like a big jumbled up mess, but this is actually a conic that we know how to graph. We just have to be able to put it in that form. And to do that, we're going to use a process called completing the square. So step one of completing the square is I'm going to rewrite the equation. I'm going to put all of the x's in parentheses, and I'm leaving this space here intentionally because we're going to fill it in. Now I'm going to put all the y's in parentheses, and again, leave this space here intentionally. Any constant, I'm going to move to the other side. So 6 gets moved to the other side, and if I move something from one side to the other, I have to actually subtract, so it would become -6. Step 2 in completing the square means I'm going to divide the coefficient of the x term b. So this number right here, okay, that would be b. I'm going to divide it by 2. So 6 divided by 2 gives me 3. And then I'm going to square that, and that is equal to 9. That number I'm going to add in that space that I left here. Okay, this is called completing the square. So I take b, divide it by 2, and then square it, and that's the number that I add here. And then going back to what you learned in 7th grade with solving equations, if I do it to one side, I have to do it to the other. So I added 9 on this side, I have to add 9 on the right side as well. Then I'm going to do the same thing with the y's. So I'm going to take 2 divided by 2, that gives me 1, and 1 squared is equal to 1, so I'm going to add 1 in this space, and also add 1 to the other side. The whole point of doing that is to create what's called a perfect square. So now I have a perfect square here that I can easily factor. All right, whatever the square root of c is, that's what goes here. So x squared plus 6x plus 9, if I factor that, I would get x plus 3 times x plus 3, or x plus 3 squared. Same thing with the y's. If I did this, I would have y plus 1 times y plus 1, or y plus 1 squared. So we created an expression here that can be factored into a perfect square. All right, and then when I add -6 plus 9 plus 1, I get 4. Now this is a circle. Okay, so now that's a conic that we know how to graph. It's in standard form for a circle. There's my center, -3, -1, and the radius is 2. All right, so you have 2 examples here for you to try. Why don't you go ahead and pause now, try these, and then come back and we'll have the answers there. Okay, those are the answers that you should have got. So if you didn't, just put a star there or something, and then you can ask me about it when you get to class. All right, there's a special case here for completing the square if the square term has a coefficient other than 1. So when we did the first examples, it was just x squared, just y squared. When there's a number in front, you have to do things a little bit differently. You're going to start the same way, though. You're going to group your x's, leave your space, group your y's, leave the space. But your first step is going to be to factor out that leading coefficient. So I have 4x squared here. I'm actually going to divide everything by 4 and pull 4 out as a factor. So if I do that now, I have 4 times x squared plus 4x because I factored 4 out of this. Okay. Then we're going to continue our completing the square process. So I divide 4 by 2. I get 2, and 2 squared is 4. So I'm going to add 4 to this side of the equation. Now when I add to the other side, though, I have to remember that there's this 4 out here in parentheses. So when I add to the other side, I'm not just adding 4. Okay, I'm actually adding 4 times 4, so I'm actually going to add 16 to this side. So that's the tricky part that you have to remember is whatever's out here that you factored out, you have to multiply that when you add it to the other side so that things stay equal. Then just like we did before, I can go ahead and factor this. It becomes x plus 2 squared. So this is what I'm left with, and then 8 plus 16 is 24. Now this step 4 says since it's not a circle. Well, how do I know it's not a circle? If it were a circle, the number that's in front of the x would have to be the same as the number in front of the y. So the coefficients of x and y have to be the same for it to be a circle. These are not the same, so it's not a circle. Right? If it's not a circle, then it's an ellipse, and so it would have to be equal to 1. So in order to get this equal to 1, because that's my standard form for an ellipse, I'm going to divide everything by 24. Okay, because it has to be equal to 1, so if I divide by 24, I have 1 on this side, which means I have to divide everything by 24. And then I'm just going to simplify these fractions. So 4 over 24 becomes 1 over 6, so I have a 6 underneath my x, and then 3 over 24 becomes 1 over 8. So now this is an ellipse in a form that we know how to graph. Again, you have 2 more examples, so you're going to try these examples and pause the video now and then come back for the answers. Okay, that's what you should have got for those 2. So again, take a look at those. If you didn't get them, just make a note and then you can ask questions when you get to class. And that is all for completing the square.